It's so, we're pivotal right now.
Good.
Let's
we'll
get
get
going.
there. A beautiful stretch of California's central coast, home to sea otters, the great whale migration, the wild and spectacular cliffs of Big Sur, and the numerous charming beach towns like Santa Cruz, Carmel, and Pismo Beach. The soil and climatic conditions found in the 500-mile coastline stretching from San Diego to Santa Cruz are optimal for strawberries, with yields ranging from 40,000 to 90,000 pounds per acre, which is twice that of Florida, the second largest producer, and 10 times that of most other states, which is why California is the most important source of fresh strawberries for the United States. Chances are the berries you eat come from here. To find out more about California berries, we visited Mark Bolda, a University of California Cooperative Extension farm advisor for Santa Cruz County.
In Santa Cruz County, we have about 3,500 acres, and in North Monterey County, which again is up against the Monterey Bay, it's another 10,000 acres, so about 13,500 acres. That's out of a total of maybe 36,000 or 37,000 acres in California. It's probably good to note, and you've probably heard it, California strawberries compose 86% of the strawberries consumed, fresh strawberries consumed in the United States.
For more than 60 years, this area has been home to a thriving strawberry industry. Critical to successful strawberry production has been the management of soil-borne diseases using pre-plant soil fumigation, especially with methylbromide. But today, the viability of this industry is being threatened by the emergence of more severe diseases due to the loss of soil fumigation chemicals. Changes in soil fumigation have forced growers to adopt new practices, which has led to new levels of disease for which we have little ability to manage. To fumigate soil, chemicals are injected into the soil, which is immediately covered with a tarp that remains in place for several weeks. The benefits include control of soil-borne pathogens, weed seeds, and nematodes. In addition, fumigation provides a more reliable and even production season, which greatly helps growers mitigate risk. Important when the plant establishment pre-harvest cost is roughly $11,000 per acre, and total seasonal cost is around $47,000 per acre. However, because methylbromide was identified as an ozone-depleting substance, regulations require a phase-out of methylbromide use. This is likely to be completed in 2016 for California strawberry producers who have been permitted continued use through a critical use exemption. To understand what this phase-out process means to growers, we met with Steve Koike, who is a University of California Cooperative Extension plant pathologist on the Central Coast. We asked Steve, what changes have you been seeing during this phase-out of methylbromide?
Two changes. One, of course, they're not using the traditional methylbromide chlorpicrin fumigation anymore. They're using alternatives, or they're doing straight chlorpicrin, but they're no longer using that combination very often. And then the second one is how they're applying them. In many cases, they're no longer flat fuming. They're no longer applying these to the whole acreage where the strawberries are planted. What they're doing is they're erecting and putting up the beds first, and then applying the fumigants only to those beds. The changes we've seen since the switch from the methylbromide model, we now are seeing some soil-borne pathogens that we didn't see in the past. The two new major problems that strawberries are facing, and that's fusarium wilt and charcoal rot. All the coastal major producing areas have both these pathogens now, and it really is coloring the future of the industry. We're really concerned about the viability and the economics and the disease management practices for the industry now.
The resurgence of familiar disease problems and the emergence of diseases new to California strawberry production require careful study of the biology of the fungal pathogens responsible for these diseases. Soil-borne diseases are typically caused by fungi and fungal-like organisms, and in Dr. Tom Gordon's lab at UC Davis, we specialize in these diseases. Dr. Gordon will describe how pathogens cause diseases in plants and the effect of infection on the plant.
Soil-borne diseases begin with an infection of plant roots. From there, the pathogen can move into the crown of the plant and restrict the flow of nutrients to leaves and developing fruit. This is a plant that has been inoculated with the vascular wilt pathogen, and you can see that it is stunted with yellow leaves relative to the plant that has not been inoculated. So, not surprisingly, plants suffering from soil-borne diseases can yield little or no fruit.
Alternative chemical fumigants have been developed, but state regulatory pressures may soon render them unavailable too. Organic farmers, as well as backyard growers, grow strawberries without reliance on chemical fumigation. What's important to remember is that fumigated fields produce very high yields, and they require large yields in order to cover the costs of their operations, which are labor-intensive. A yield of 70,000 pounds per acre in a 100-foot bed with 2 rows of strawberries would translate into about 700 pounds of berries in a season. That's a lot of berries. Rod Cota is a longtime strawberry grower in the Central Coast who grows both conventional and organic berries. We visited with him to understand his experience with organic strawberry production.
The biggest thing I noticed the first 2 years is, I didn't come up with the production, not like the conventional. I mean, I could generate about 8,000 trays, 9,000 trays per acre conventionally. My first year organic was like 4,000 trays, and I'm like, oh no, what did I get myself into?
Without fumigation, we lose the greatest tool we have for controlling soil-borne diseases, which are nearly impossible to eliminate once established in a field. Today, researchers and growers alike are working to develop new strategies to manage the soil-borne diseases that are already appearing in fields up and down the coast. Integrated disease management tools like crop rotation, improved variety selection, and equipment cleaning to prevent spread are being more widely adopted. With less chemical control options, one must begin to consider biological controls. In other words, how to monitor and manage soil microbes to promote plant health. Biological control is regulated by beneficial soil microbes that can prevent soil-borne pathogens from causing disease. We know that soils have the capacity to support microorganisms, and that soil microorganisms can provide disease suppression. What we need to better understand is how our agricultural practices, like tilling and the addition of amendments like compost or crab shell meal, affect the soil microbial community, and how we can implement practices that generate biological control that suppresses disease. Dan Shalimi is a plant pathologist who has been researching and developing alternatives to soil fumigation for many years. Formerly with the USDA, he now heads a research team for Driscoll's Berry Associates, the largest berry growers in the U.S. We went to him to hear about non-chemical soil-borne disease management.
Organic strawberry growers in the Central Coast, California, tried to manage damage from soil-borne diseases by adopting practices that encourage the buildup of healthy soils. And by healthy soils, I mean soils that are rich in organic matter and that are a habitat that's conducive for beneficial microbial soil communities.
Non-chemical alternatives, such as steam treatment and practices that induce anaerobic soil conditions, are currently being evaluated. Also of interest are cultural practices that elevate the activity of the microbial community in order to inhibit soil-borne pathogens, such as amending the soil with compost. Compost is used by both conventional and organic growers, yet little is known about the differences between composts and the extent to which they influence microbial activity and plant productivity. Our research seeks to characterize these effects for 4 very different composts that are available to strawberry growers on the Central Coast of California. Our first objective is to evaluate the potential of each compost to provide disease suppression. Disease suppression is a well-known phenomenon in which disease fails to develop in a plant despite the presence of the pathogen. Qualitative and quantitative components of the soil microbial community are thought to be responsible for this. Naturally occurring suppressive soils exist around the world, as well as cases where we have been able to generate suppressive soils through production practices. Because compost is a source of microbes and food for the microbes, it has long been identified as a potential tool to manipulate the soil microbial community. Dr. Gordon will describe one of the assays we use to evaluate the suppressive potential of compost on soil-borne pathogens.
To determine the extent to which compost amendments have this effect, we can quantify the frequency of infection by culturing plant roots on a medium that supports pathogen growth. In this case, we are looking at Verticillium dallii, the pathogen that causes verticillium wilt.
Our second objective is to identify differences in the nutritional components of these composts. This is done through traditional soil lab techniques using samples taken throughout the season with which we can generate a soil nutrient profile over time at each field trial location. Third, we want to understand strawberry root development in commercial fields when amended with different composts. Preliminary results suggest differential root development based on compost type. Root development is evaluated from soil cores taken from our field trials, from which roots are sieved, cleaned, scanned, and analyzed to determine total root length. Lastly, we want to understand how composts affect the bacterial community in soil. We will be comparing the effect of 4 composts on bacterial diversity in a field fumigated with methylbromide and an organic field. The results should provide insight into the differences between microbial communities in soils with and without fumigation and how they are affected by compost amendments. To conduct this research, we implemented 5 field trials in Northern California to evaluate the 4 compost types. The following is a gallery of images showing the establishment of the trials, management, and data collection conducted throughout the year.
All right, let's pick it together.
We hope the information we learn through the field and lab trials will help to narrow the yield gap between conventional and organic strawberry production and provide additional tools for soil-borne disease management. To follow our research, please visit our website at www.gordonlab.net/composting. We can no longer rely on pre-plant soil fumigation to control soil-borne pathogens. So to maintain a thriving strawberry industry on the coast of California, more tools are needed to manage soil-borne diseases. This has inspired greater research into measures that create healthy soils with a robust microbial community to help diminish the impact of destructive plant pathogens. Thank you for watching, and we hope that you have a new appreciation for the challenges that strawberry growers face in producing the berries that find their way to your table.
It's pivotal.
We don't let anybody in to do other growing practices because of what I've been seeing around town with disease coming in, with harvesting equipment, or I don't want to take that chance with disease, because once a grower gets the disease in, very, very difficult to get it out.
The end. Thanks for watching.